All right. Can everyone see or hear me?
Yep.
All right, cool. Just let me move this off the way. All right. Thank you everyone for coming here today. And today we will talk about the truth behind MongoDB. They will want you to know by John Page, our wonderful guest speaker, for being here today. And now just gonna show some quick agenda. First, introduction from TorontoJS, and then John Page will talk about MongoDB, and then some pretty awesome Q&A section or more programming. And just also be mindful, like ask some really cool question, like for the John Page, and keep it on the topic, and we'll be really appreciate that. And then afterwards, just like extra networking times. And just quick introduction about TorontoJS. We are a volunteer-run nonprofit corporation that aims to support all in their journey to learn and share their passion for JavaScript and by extension software development. And we have around 12,000 members on Meetup, virtual and in-person events, around 5,800 members on Slack, 900 plus on Guild, and 50 volunteers. So if you'd like to partner up with us, we can have a chat about it. And you can contact us at sponsor@torontojs.com. And for the upcoming events, for the following Tuesday, April 2nd, and we will be discuss about build a modern user interface with Chakra UI. So if you're interested in checking out the course and have some really cool discussion or have some questions, please make sure to RSVP at the QR code over here. And then the most important thing is about code of conduct. We are dedicated to providing an abuse-free, harassment-free event experience for everyone. And we do not tolerate any abuse, harassment, or anything in any form. And the detailed version can be found at torontojs.com/p/code of conduct. And if you feel something is not right, please contact me, Ken, or Dale, or you can report at torontojs.com/pre/report. And also, thanks for joining us. You can join us on the Slack channel here. And if you want to get involved more in the community, you can scan the QR code right here. And that's it for the introductions. And also thanks, Dale, you for being here, like helping us out, and we appreciate that. And yeah, Ken, would you like to do some quick introduction for our guest speaker, John Page?
Sure. Thanks everyone for coming today. I'll keep it really short. I know you've been waiting impatiently. John, thanks a lot for joining us today. John's been with MongoDB for over 10 years. He's got over 18 years industry experience with NoSQL technology. John's an expert on the topic. We're really happy to have you here today. So without further wait, John, we're excited to hear your talk.
Cool. I'm assuming you can hear me, and I'm going to share my screen, or at least I'm going to share a window, and we'll see if this technology stuff works. Someone want to tell me that they can see my slides?
It works.
You can.
Yes.
Good. Okay. So let me do a little introduction for myself. Because I think Ken got one thing slightly wrong there. So I actually have over 28 years of NoSQL experience. So about myself, I'm a full stack developer. I originally trained as a geologist so that I could find silicon, so I could build my own chips. I'm handy with a soldering iron. I built my first computer from scratch, and by from scratch, I mean I didn't use any pre-existing chips when I was 14. Which would be back in the 1980s. And I have built everything all the way up the stack. I'm a polyglot developer, so I kind of regularly write JavaScript, Java, and Python, and then I do things like C# and C and C++ as and when I have to. And I do everything all the way up to the highest form of programming, which is writing documentation, which I quite like doing as well. This talk is, sorry, I'm looking over to the side because I've put the window with my own face on it off to the side. Let's move that a bit better. So this talk is not any way an official MongoDB talk. The things I will be telling you are things which lots of people a group of people in MongoDB know. They're a thing that in my current role, I go out and I tell customers, but they are a long way from our official marketing message. So let's take it from there. So we look back a little bit here. So this was basically what was on MongoDB's web page back in 2007, 2008 or so. And this is, how MongoDB sold itself to the world. It was going to be this high performance open source database, JSON style documents, full index support, query against it, fast in place updates. So, it was fast, and you could store JSON and you could query JSON against any set of fields, which is all great. And that's probably a reasonable description of what it was. But MongoDB now has over 1,000 developers, and we've been at this since 2007. So unsurprisingly, the product is not exactly the same as it was back then. So what I wanted to talk to you about was what MongoDB is now, because that's not what MongoDB is at all. But that's what a lot of people think it is, because that's either a first impression or they learned what MongoDB was a long time ago, and MongoDB has evolved significantly. So what is MongoDB 17 years later? It's officially a modern document database. But do you know what it really is? It's an RDBMS. It turns out that MongoDB in 2024 is, to all intents and purposes, and by any reasonable test, a relational database management system. So that's a slightly controversial viewpoint, and you are not going to find anywhere on MongoDB's website a claim that MongoDB is an RDBMS, but I'm kind of telling you that it is. And this is why I think it is. So we just talk about data in a relational database. I'm going to assume here that everybody is reasonably familiar with RDBMS as a concept. So if you're not, and you've only ever used MongoDB, or you've only ever used some kind of mobile object database, my apologies, because I'm only going to go so far into explaining what a traditional relational database is. On the other hand, I'm sure there's some of you who are very, very au fait with it. So in a relational database, we store data as rows and columns in tables, like so. And we quite often will look at those rows and columns, or we'll load them from CSV files. So we can represent that data kind of as a CSV file. Now, it's a bit problematic because there's no way of specifying the data types, but that's fine. The table itself knows what the data types are. I can also potentially take that same row from my database and display it as a piece of JSON. That doesn't mean it is JSON. It doesn't mean the database is storing JSON. The database is a database storing in its own proprietary internal binary format. But we can view that data as JSON. And I want to make this point because MongoDB's relationship to JSON is the same thing that when I refer to databases, I'm going to refer to Oracle, but I actually mean all relational databases, because Oracle does pretty much everything else does, just costs more. Where was I going? So yeah, we look at this, but the relationship that MongoDB has to JSON is the same relationship that Oracle has to CSV. And so if you're going to call MongoDB a JSON store or a JSON database, you may as well call Oracle a CSV database or a CSV store, which it really isn't. So what we do in MongoDB that's kind of very, very different, the first thing we do differently is we have the idea that a document, a map of fields to values, is a data type, just like a date or an integer or a double. So it's effectively a grouping of fields. If you look at this example, instead of having 5 fields all called address underscore number, address underscore street, address underscore town, I've kind of grouped them together. I've said here's a bunch of fields under the and they're all address fields, which is kind of nice. Because you can say just fetch me all the address fields, and you can also use it for scoping queries. Now you might be surprised to hear that this feature is also available in Oracle and Postgres and other relational databases, and you might be really surprised to hear that we're not talking about JSON. in Oracle and Postgres, this is called a custom object. You define a data type called an address and certain fields for it, and you can store addresses. It's exactly the same idea. So the fact that we can have this nested thing here, to my mind, that doesn't say MongoDB is no SQL. It doesn't say MongoDB is not a relational database, because this is a feature that relational databases have. So I'm happy to go one way or the other and say, yeah, this means it's not a relational database, but by the same token, neither is Oracle. Now, the next thing that MongoDB does is it tackles this problem. So this problem is where you have what's traditionally called a weak table in a relational database, but it's a one-to-many relationship. So you have a thing, and a thing has a repeating group of attributes. So for example, a person has more than one telephone number. Now, in the original rules for RDBMS, it says you are not allowed to do two things. One, you're not actually technically allowed to have a column called mobile phone number and a column called house phone number and a column called work phone number. That breaks first normal form. So there's like a bunch of rules and everybody goes for third normal form, but to get to third, you have to be obeying the rules of second and first. And it breaks first normal form if you do that. And the reason is because you could have any number of phone numbers. So you're not supposed to have a field for each one. I'm liking the nods I'm getting from Dale. So somebody's obviously is digging this. So the other thing that's said quite explicitly for relational databases and for the rules of first normal form is you are not allowed to have a column type which contains multiple values. So you cannot have arrays as a data type in a relational database. And that's literally rule number one. If you look on Wikipedia, normal form says you cannot have arrays as a data type, which is a shame because MongoDB has arrays, but then so does Postgres, so does Oracle, and they can be arrays of objects. So technically, something like we're seeing here, where here is a row, it's got a customer ID, it's got a name, it's got a date, and then I'm saying that the phone column is of type array, and it's an array of objects, each of which has a type and a number. So this is how you can model data in MongoDB. And I don't know if my next slide is going to tell me, so I should probably explain why you do this. Why would you do this? Well, these, and we can even look at that as a piece of JSON. So MongoDB can model a row, but we break the rules because we say you can have arrays and you can have objects in those arrays. But then we're not doing anything that Oracle and Postgres and etc. don't do here. And we can display this as a piece of JSON. So what we're really saying is we can take a piece of JSON like this, but we can store it as a single row. We don't need to break it down into two separate tables. Why does this matter? This matters because quite often when we program these days, we want to retrieve a relatively complex object from the database. And we want to be able to save a complex object, and we want to be able to perform operations that take into account all parts of the object. So for example, fetch me this person and all the phone numbers where the phone number is this. To do that, if all of this is broken down into separate tables, is relatively expensive. One, because of the cost of looking up the indexes and finding the data, but also even more so for a concept called data locality. So one of the tenets of computer science is literally the further apart data is, the slower it is to use it together. So if you've got 2 bits of data which are on the CPU cache, that's faster than if one of the bits is on the L2 cache, which is not built into the CPU itself, which is faster than if it's in RAM, which is faster than if it has to go and fetch it from disk. And every time you go up one of these, you go up like several orders of magnitude. So by taking an object that we want for our programming and breaking it down into hundreds of rows across half a dozen tables, it's actually really slow to be able to retrieve and pull that stuff together. And the simple logic for that is when people build systems that use these objects, they put caches in front of them. My take is, if you have to put a cache in front of your database is not fit for purpose. If your database can't cope with objects without you having to cache in front of them, there's a problem. So if you have to basically get rows, pull them together, convert them to objects, and then kind of store those, that's not right. So in MongoDB, because we have arrays and because we have nested objects or documents or special data types, call them what you like. And we can nest those all the way down like turtles. It means we can take any object and we can store it in MongoDB. And we can retrieve it from MongoDB. So my argument here is going to be MongoDB is a relational database. Interestingly, MongoDB gets called a document database. One of the reasons for that is that even though it stores and retrieves objects and works by objects all the way, object databases had a really bad rap back in the late 2000s. And so they didn't want to call it another object database because people would go, yeah, they suck. So MongoDB is a database that can store objects. Great. And we can query them. And we can interact with it by objects. And I would say that one, I've said here, but you can do this in Oracle, but you can do this in Postgres. And again, not talking about JSONB, not talking about JSON in either of those databases, talking about the actual native structure. My argument would be that that's a good, storing stuff as JSON in a database is probably not a great move. It's a little bit kind of unstructured and it's very much untyped. Storing it as objects and arrays of objects and having these much richer ideas of a row is good. The difference between MongoDB and those other databases is that's where we started. So we have great APIs for that. We are not using SQL explicitly, although I'll come back to that later, because actually SQL is not the best way to interact with that data. And this is why you don't see many Oracle or Postgres systems built with these much kind of richer objects. I also think there's some limits. I think you can have arrays of objects, but I'm not sure that those objects themselves can have arrays in them. But I'm not an expert there. So don't think of MongoDB as storing JSON, and don't think of it like JSONB. Think of it much more like storing rows that can just be a bit more depth, so it can have objects in. Why? Well, this is my radio control car. It's a cute radio control car. I can grab it off the shelves, and right now I have 13 dogs in the house because we had a litter of 10 puppies yesterday. But generally I have 3 or 4. And so I like to grab my radio control car and use it to chase the dogs around the garden, particularly with puppies. But it didn't arrive looking like that because it's quite a nice radio control car. It arrived looking like this. Good RC cars come as kits and you have to build them from all the pieces. Now, the thinking here is then when you snap something, you can just buy a replacement like a real car. But I don't store it like that. Because if I stored it like that, it would be really no fun to play with. Because every time I wanted to play with it, I'd have to build it again and then chase the dogs and then take it apart. And that's kind of the logic behind MongoDB is, if you're using your data in a particular way, store it the way you're planning to use it. Don't bust it down into every possible model on the grounds that you might potentially want to put it together differently. Make the cost of accessing the data cheaper. And ultimately, why use MongoDB? Well, I'll get to that bit at the end. So, is MongoDB a relational database? Well, people say, no, of course it's not, because it's schemaless and untyped. Well, that's just, to be frank, ignorance. MongoDB in its early days didn't have schemas. And you couldn't enforce a schema, and you couldn't set rules against the schema. And it was never untyped in that, every value stored in there is stored as a data type. There are like 5 different numeric types. Dates are stored as dates, which again is not what happens in JSON, but it does happen in JavaScript. So in JavaScript, when you save a date in MongoDB, it doesn't store it as a string, it stores it as an actual date, and it gets it out as a date. And what's really nice is if you get it out from Python or you get it out from Java, it still comes out as a date. So MongoDB inherently, the way you interact with it is via some kind of object relational mapper. Anyway, MongoDB isn't schemaless. So I have a little tool that will do this for you, but you can create a table in MongoDB. By default, MongoDB will create a table for you. Yeah, it'll just make it. And then as you add things to it, it will update it for you. But if you want to go in up front and say, here's how I create it, I can take this piece of SQL, and here is the command in MongoDB to create it. And we'll see we're not only saying, here are the fields and here are the data types, but we're also able to set other requirements against them, such as they can't be null, they can't be non-existent, and by the way, age must be greater than 18, and first purchase must be less than last purchase. So we can set all those integrity constraints on our data. And I strongly recommend that people do that. Once you've written your system, version 1, make sure you've got a field in your data that says I'm using version 1 of the schema. So every record says I'm a version 1 record, and then apply this, because this will prevent you getting a bunch of the errors that can happen in MongoDB where somebody mistypes a field and suddenly your data is broken. So MongoDB is definitely not schemaless, because you should always have a schema for your data, and it takes as long to design a schema for MongoDB as it does for anything else. But also, it's not untyped. Make sure you're enforcing it. People say MongoDB doesn't have ACID transactions. You have to do a bunch of hoops in your application to get proper ACID, atomic, consistent, isolated behavior. It's absolutely not true. MongoDB has had ACID transactions for 5 years that work exactly the same way as in a relational database. Here's the JavaScript code. So I've got connected, I'll take my client and I'll start a session. So I can have multiple sessions, each of which is dealing with its own transaction. Start a transaction on that session. So just walk through what this code does. I will say, start me a transactional session, start a new transaction on that. I want to insert a record inside that session. I'm going to insert another record, but this time I'm not going to insert it as part of that session, so I can pass the session to this. There's a couple of different ways you can do this syntax, by the way. This is probably not the one you'd see for the Node driver. This is a slightly different JavaScript driver. And then I'm going to do a find inside my session. I'm going to do a find outside my session, commit my transaction, and then do a find after it's committed. Again, the transaction is gone. So what I see there is that I insert 2 records, one as part of my transaction, one just as normal. I see the one inside my transaction, but I don't see the one that was inserted after the transaction started. Because once I start a transaction, I see a snapshot of the database. Nothing will change. I don't see other people's changes after I've started a transaction. Meanwhile, outside, I don't see the record I added inside the transaction. And afterwards, I can see both of them. So transactions have all of the properties you expect. You have the atomic, nothing happens in the database until you commit. You will see the changes, but all the other changes appear instantly. You have consistent in all of the rules about, typically in MongoDB, it's only going to be about uniqueness constraints. We'll talk about that in a moment. They're all applied. It's isolated in that once you start a transaction, your database is frozen in time. You see no changes. Reads are repeatable. Meanwhile, nobody else sees your changes. And of course, durable is just a thing with MongoDB. When we commit, we commit. And we not only commit to one server, we commit to a bunch of them. So the next question is, does MongoDB enforce foreign keys? And the answer there, I'm afraid, is no. So if you're going to call me out on that one and say MongoDB can't be a relational database because it doesn't enforce foreign key constraints between tables. And for those of you not familiar, a foreign key constraint basically says this value in this column must exist somewhere in this column in a different table. So basically, it's things like you can't set the country to be a country that isn't in the list of countries. Or you can't have a bunch of invoices for a customer if you don't have the customer record. And if you try to, say, delete the customer, it will either automatically delete all their invoices, or it will say, no, you can't do that because you've not deleted their invoices first. So your data has relationships between things, but you cannot break those relationships. Well, I'm sorry, MongoDB doesn't actually enforce that. It's not that we couldn't. We talk about it now and then. It actually would be relatively easy for us to add, given all the other things we have, but we don't believe that it's the best way to actually design schemas and enforce this stuff. And we do that from the basis that we work with lots and lots. I work with MongoDB's 50 biggest customers who work with relational databases. They're mostly insurance companies and banks and car companies, quite boring things. But what we see most of the time is that in larger databases, foreign keys are normally turned off. They're too expensive. They're too painful. People that have worked with big, relational databases are like, foreign key constraints are not worth the effort. I would also, in my argument that foreign keys are not necessary for a relational database, say that in the first 12 years of its life, including when it was the most deployed relational database in the world as part of the LAMP stack, MySQL did not have foreign key relationships. So if you're going to argue that those are necessary for a relational database, we have to argue that MySQL was not a relational database for 12 years, which is an argument that I've heard, but I'm not sure I believe it. So, sorry, don't do foreign keys, but then I don't think you really need them. So what about SQL? Do you need to have SQL for a relational database? Historically, you didn't, because the original paper on relational database makes no mention of SQL. SQL came considerably later, actually. But MongoDB is a no SQL database. So I find SQL quite interesting. It's an interesting thought exercise that imagine a world, and no, you're the Toronto group, so you're going to get this. Imagine a world where the pioneers of databases had not been the Americans or the Brits. I'm not sure who really was the pioneers of databases. Let's say it was the North of how do we do this? Do we call them Americans? We can't call them USAians. The North Americans who are not Canadians. The other ones. Let's say they weren't the pioneers. The pioneers happened to be the French. We wouldn't have SQL today. We'd have LDRS, language de requête structurée. And it wouldn't be some bastardized form of English. We'd all talk to our databases in French. Selectez nom d'un client, la catégorie d'un premium ou basique. It's my French is atrocious. Un vache espagnol, as they say. But it's weird. SQL is English, and yet we not only pretend that we talk to databases, we sometimes ask developers to write things in English to talk to a computer. Now, I know AI, yeah, whatever, but it's still a bit weird. Worse still, we have one computer talking to another computer discussing their needs in English. No wonder this gets confusing. So, MongoDB, when we started, we're like, this is just crazy. Don't make computers talk to each other in English, because people do injection attacks and they get confused, and English is not, the best language out there. And by the way, most developers are, by 2007, weren't actually writing SQL to talk to a database. They were using libraries. They were using objects. They were using object relational mappers. They were using Spring Boot and things like that. So MongoDB started off with the idea of, let's go ORM first. Let's go ODM first. Let's have ways of querying and working entirely from APIs and objects. And let's not have SQL, which was originally intended as a user interface. What I would say is that nowadays MongoDB does have SQL, but we have it back where it's supposed to be as a user interface. So if you're using MongoDB in cloud, then you can also get SQL, and you could run SQL from the MongoDB shell, read only. So we have it, but we have it not for the programmers, because we don't really think programmers want to write SQL. And the fact that programmers use all of these different libraries to work with data instead of raw SQL kind of implies that's true. We have it for business analysts and statisticians and people who want to work with the data, but they're not programmers. And therefore SQL is maybe the user interface for them. But SQL, as people say, is really sophisticated. Well, MongoDB has a thing called the aggregation framework. And actually the way we run SQL is we take SQL you type in and we translate it to our aggregation language. Now, our aggregation language is a kind of, it's actually an imperative programming language written in a functional style. But it is Turing complete, which means you can actually compute any computable function in it or use it for anything. To give you an idea of what you can do, well, how did we know it was Turing complete? We implemented this game of life in it. So we made the database play game of life internally by writing effectively like an SQL statement equivalent that played game of life. We also use it to generate fractals now and then. And once, I'd say for a bet, but actually it's because I thought, I wonder if I could get rich doing this by using all of those badly secured MongoDB instances on the internet, I wrote an aggregation pipeline, a query effectively, that could mine Bitcoin. So I have, and I've published an aggregation pipeline in MongoDB capable of mining Bitcoin. Now, once I finished this, and by the time I got the final pipeline at the end, it was 16,000 lines long. It turned out it wasn't very quick. And there are good reasons for this. Like MongoDB's aggregation pipeline doesn't actually have any bitwise operators. So I had to implement all of the things like bitwise and OR and XOR by doing shifts and anding things, all with floating point maths. I say the code is hilarious if you look at it. So the outcome of this is it did manage a grand total of, wait for it, 4 hashes per second, at the point at which kind of 4 trillion was what they were getting out of dedicated mining rigs. So it was never going to make me rich, kind of a trillion times too slow, but it was an interesting exercise in what can you actually do. What you can importantly do is you can do anything you can do in SQL and a bit more, and you can do your business processing in the database, close to the data. And then joins. So it's not a RDBMS if you don't have joins. It's no good just relying on the pre-joined object data. You have to have relationships and you have to do joins and you have to do them in the server so you don't have to fetch all the data back and join it in the client. Couldn't agree more. The thing is, MongoDB has, actually technically has 5 different ways of doing a join, or at least ways of doing a join that do it 5 different ways. You know, you can do $lookup for nested loop joins. You can do $lookup with pipelines for non-correlated subqueries. So that's basically the same as like nested selects. You can use union and group to do a hash join. You can actually read data and then, because of the way that the pipeline of the query language works, you can actually like read one table and then embed that whole table inside your query in order to do kinds of joins as well. That's a really quick way of doing it. So MongoDB has joins. It's not optimized to do joins as well as Oracle is, because Oracle has to join everything. We're like, look, all your joins that need to be quick, just do them up front. And it's also, and this is actually a big difference, is we figure we're going to be more imperative and stuff. We're going to ask the developer to think about the best way of doing it. You know, when you want to join A to B to C, we make the developer decide the order. Whereas with SQL, you just describe what you want and you let the optimizer figure out how to do it. So it is a bit different in that we expect a little bit more understanding from the developer, but we give them the ability to actually get way better tuning and performance. So other things people say are, do MongoDB have stored procedures? Which is a great question. The simple answer is no, but as ever, there's a kind of more subtle answer that actually we don't, but we have the same way of doing most of the things. So stored procedures are a way of basically building a sort of a SQL statement and putting it inside the database and being able to call it as a function. Now, the question is, why would you do that? And one of the original reasons for doing that was when you perform a transaction, you want to begin a transaction and then make a bunch of changes to the database and then commit that transaction. Now, you could do that from the client. Begin, do this, do this, do this, do this, commit. But then stuff is locked inside a transaction and it's unavailable to other things to be able to change. And so you want your transactions to be as fast as possible. So you might want to take that business logic and shove it on the server so you can basically go begin a transaction, do all this stuff, and just send one call to the server that knows what to do and back it off. MongoDB doesn't let you store that on the server, but we do have a way of pushing a bunch of work to the server in one go between what we call expressive updates and being able to do bulk operations where we can send a bunch of commands to the server in one go, means that we don't have to have a transaction open for a long time. We don't have to call begin because the first operation we send will also begin it. And we can send a bunch of operations and then just commit it at the end. So the performance reasons that these were added, we cover that in a different way. The idea that you would store part of your code inside the database as a way of managing code and reuse seemed like a great idea in the 1980s and early 1990s. I can promise you most enterprises now are like, we wish we had not put our code inside the database because it's making it really hard to modernize any of it. All of our code should live, you know, in some proper source code control system outside the database, in our microservices, in our other code, as long as we can do it performantly. And then the final thing I think I would say is that, again, if you're using MongoDB in cloud, we have serverless JavaScript functions, which can be called by triggers. So if you want to have stuff that asynchronously runs to go and do something, I mean, I've written stored procedures in Oracle that automatically take your Oracle changes and push them to MongoDB, for example. So people can update their Oracle system, but that's live, well, asynchronously replicating to MongoDB. You can do the same sort of concepts in MongoDB. So it can see on any change to the database, that can trigger a piece of code that can make other changes to the database, update a materialized view, send an email, you know, any kind of processing you want. So pretty much anything that you would want to get from stored procedures, there's another way of doing it, which is equivalent. So what, you know, I've spent a long time now explaining to you why MongoDB is a relational database. So the problem, good question would be, so why bother? Why not just use any other relational database? And the answer is that there's a philosophy here. With MongoDB, you're designing a schema for your use case, an optimal schema for your use case. With a relational database, it's designed to let you design a schema and model your data so it can do absolutely anything. So MongoDB is about a more optimized way of doing the thing you need to do rather than a generic way of storing the data. Originally, because the idea was that, you know, there'd be one database for an organization and it would be used for every use case in that organization. How do we do it? We have documents, which let us group the fields together. We have arrays. Between documents and arrays, it means we can co-locate that data, like I said with the radio control car. It makes it quicker and easier to query. It makes it quicker and easier to retrieve complex things. We allow you to have flexible schema. So although you can lock down the schema, you can have, you know, this part of the schema is locked down, but you can also, when you're developing, you can be much more flexible. You can also say, well, I also need to store this arbitrary objects that come in. You know, I've got all of these, you know, fixed fields that I've got, but I also could get a response from a web server that I have to log that's a JSON document. Great, you can mix and match flexible but still queryable schema with everything else. And the big thing about MongoDB is this object-based API. It's just way easier to code with MongoDB than it is with most relational databases. So why does it matter? It's more efficient. For any given workload, if you use MongoDB correctly, you can do twice as many transactions per second. You can use half the hardware for the same amount of business processing. It's more productive. What we find is developers find it easier and can iterate faster with an object-first model. And this doesn't apply to everybody at all. It's more scalable. This idea of storing a bunch of stuff together is even more important if you then are splitting your data across multiple servers, because you really want all the data you need to do a thing to be on the same server. You don't want to have to make network calls between servers, pulling data together, because in that model of CPU to RAM to cache to disk storage to network is so slow, it's horrible. And that's it. So thank you. And I did take a little longer than I was supposed to, I think, but please fire away with some questions. I did see that in your code of conduct that you're not allowed to be really mean to me about MongoDB, but, you know, I have thick skin.
All right.
I think John is saying that if you have a strong argument in regards to SQL, he's welcoming the question.
But yeah, guys, please go ahead and ask questions for Mr. John Page here.
I have a question, John. When you mentioned about one of your, I think it was your second to last slide, or maybe the third to last, you mentioned like what's the nuance? You know, you mentioned that SQL is more general purpose, whereas MongoDB will try to really build around what you're trying to do specifically. assuming I understood well. And
It's not
so,
it's not the SQL side of it, it's the normal form side of it. So just to differentiate between SQL as a language versus relational schemas, traditional relational schemas.
so would you say, go ahead.
Yeah, so if you wind back in time to why do relational databases exist, or what existed before them? So before them, an organization, in the birth of computer science, to be fair, a business would have multiple applications, each of which would have their own data files, which weren't compatible with each other, and each application needed to know how to read and write its data files. So the theory behind relational databases was, can we take all of those different sets of data and bring them together into a single set of data where nothing is duplicated, where everything exists once, where there's complete consistency because there is only one version of any piece of data, but all of our different applications can use it. So third normal form, the way you're supposed to model data, says you are modeling for any possible use case. Now, what then happened was, it turns out that there are performance implications with this. And so if you model your data in third normal form, your DBA will then come along and will do things like, say, this table, could you organize the rows in this table such that they're organized by, say, customer ID? So everything for one customer is stored close to each other, and it's stored in the same blocks in the database, because that's how people are querying it. So you'd have this logical view of the data, and then there'd be a physical implementation of it, which would take into account the business needs. Basically making sure that data that was used together was stored together. It's a mantra you'll hear from MongoDB. Whereas what we do is we say, look, this idea that there'll be one database and only one database for an entire organization is 100% opposite to what you're telling us, which is you want microservices all with their own databases. And nobody knows better which data is going to be used together than the developer. So let's give the developer the ability to actually decide which rows from which tables should be stored together, how we co-locate that data. So rather than abstract and then a kind of fix afterwards, which only works with one table, we're saying, hey, developer, look, you can smash tables together and store what would be two separate bits of data with, this and the rows from this table, this and the rows from this. So that's the thinking there, is it's more efficient to store the data and retrieve the data and query the data. But the data is designed for what you need to do. If you're completely pivot and need to use that data in a completely different way, it is not going to be as optimized.
Do we have any more other questions? Normally we have more questions.
Yeah, hi, Shivam this side. I have one question.
Sure.
Can you hear me?
Yep.
I can hear you. Yeah, I can't see who you are, unfortunately.
Okay,
There's
wait.
nothing is lit up, but
Yeah, I guess you can see me now, right? Yeah, so my question is like, how would you decide like when should we use like something like Postgres or like SQL, or like when should how like what should be the thought process of deciding what is the best database for this particular use case?
So if you are building a data warehouse, star schema data warehouse, do not use MongoDB. If you are building any kind of OLTP system, so something which is online, interacting with the processes of your business, with your customers, then I am not aware of any circumstance where MongoDB would not be a more efficient choice. So we're really not good at data warehousing. We're not good at that kind of large scale, broken out format. Modern players like Snowflake are great for that. But there's no use case that I'm aware of that MongoDB isn't going to be a good choice for. But I am going to caveat that with, you also need to kind of, in any technology, you need to know what you're doing. So if you just use MongoDB and you have all the same tables that you would have in Postgres, it's going to suck. If you just slam everything into one document, it's not going to work either. So, I'd say if you want to use MongoDB and you're planning to use it for, something that matters and something that's a non-trivial amount of data, you do still need to learn how to use it. You do need to learn a little bit about document schema design. You can't just throw it all together. It's in there. But as I say, I work with MongoDB's 50 largest customers. I travel around the world, going to Citibank in India, or going to JP Morgan in Ohio, or whoever. And there, you can imagine in these organizations, they have thousands of developers working on hundreds and hundreds of projects, all of which are different things that run the bank. So, there's one which lets customers, it does the order management for credit cards, actually ordering the printing of the plastic cards and the photos on them and everything else. And then you get somebody else who's built some nice little kind of web GUI that lets you design workflows for onboarding people to new accounts. It's an enormous range of use cases. I hadn't realized beforehand how many things a business writes to run its own business. And I've never yet seen one of them outside somebody going, yeah, well, actually, we're doing data analytics and warehousing, that MongoDB wasn't a great choice for. Product-wise, etc., we have MongoDB, the database. That is all about live, high-speed interaction with customers, interaction with processes, IoT, all of that side of it. At the other end of the scale, we have a thing called data federation, which lets you store your data as CSV and JSON and Parquet on Amazon S3 or Azure Blob Storage, and throw a ton of processing power at it. So that really is about store relatively unstructured data, and we will just throw literally 2,000 CPUs at a time at it and crunch those numbers for you. So if you want a data lake, as they'd call it, we're kind of good in that front, but really any kind of OLTP use case, any online transaction processing, we're probably a good choice. But you do have to learn it. It's not, I think one of the things that has frustrated me for the sort of 10 plus years I've been at MongoDB is there seemed to be some equivalence in people's minds that if something was open source and something was available for free, that something didn't require you to learn it at all. You would just magically know it. If you were paying for something, then you'd have to do training courses. But for something which was free, people thought I must just be able to instinctively use it. And it's not true. I mean, we have free training courses for a good reason. But if you don't learn MongoDB and how to use it and how some basic things work, then it's going to be like any other technology. You're going to be like, you might be able to get in the car and start it moving. You've seen somebody turn the keys. But if nobody's taught you how the lights work, then you can't drive it in the dark. If nobody's shown you how the windscreen wipers work, you can't drive when it's raining. And I don't know how well this works in Canada, but in Europe, if nobody's shown you how to change gear, you're just really not going to go very quickly. So it is important to, do the training, learn.
Yeah, that's like it got me some basic idea like how do you decide. So let's suppose if I'm building something like AI based where I'm gonna use some LLM models or something like that. So in that case, would it be a good thing to use it?
So that's an interesting question, in that it comes down to a couple of things. One, what's the data you're going to store? But the other thing I'd say is that if you're not aware of it, MongoDB, it's principally a modern document database, aka a relational database in sheep's clothing. But we also have a vector database as part of it as well. So if you want to store vectors and query those, that's also available. Cloud only, but that's also available to you. And you can get it for free in cloud, so that's kind of nice. So, you're saying you have an LLM use case. The question is, do you need to store any structured data? In which case, yes, MongoDB is good. Do you need to store and query vectors? Yes, MongoDB is good. I'm not sure what else you want to do with the database.
I got it. Yeah, that makes sense.
But the simple takeaway from this is there's nothing you can do in Postgres or Oracle or SQL Server that you can't do probably more efficiently in MongoDB.
So in terms of processing, like earlier you said that the way we should design our the data should be based on the use case and not the generic ones. So I think that's also a important factor where the time of querying will be also depending, like even if it's Postgres or like MongoDB, right?
Yeah, so your queries will be quicker and simpler, and retrieving your data is going to be quicker and simpler from MongoDB. But you want to make sure that you store the data in a way that's sympathetic to the way that you want to retrieve it. So as I say, the kind of throwaway comment is store data together that you use together. I actually have a sort of set of 6 rules and a process that we can walk through that, not today, obviously. There's like, given your relational schema, here's how you convert it to MongoDB. That's actually the presentation I do for customers most of the time.
Yeah. Thank you.
Awesome. Thank you for the questions. So anyone else has the questions for him?
No, in that case, thank you very much for your time. It's always good to have people listen, and nobody's been abusive about MongoDB, so that's kind of nice.
I think all of the relational database maximalists have stayed home today, John.
Oh, well, they didn't know the secret that I was going to tell, did they? Maybe I should have called the presentation MongoDB. So MongoDB is a relational database. Prove me wrong.
I could think of a couple of names that would have gotten more attention, but that's okay. John, thanks a lot for joining us today. John, it was an amazing presentation. I learned a few things, of course. I'm sure everyone else did. It was a pleasure having you today. We'll be moving on to a short networking session. Sammy, unless you have more words, I think we could probably put an end to the recording.
Yes, absolutely. But yeah, thanks again for coming here to share your knowledge with us, John Page. And also want to thank everyone for taking your time during the long weekend and joining us. And also thanks again, Dale, for being here and helping us. But yeah, let's get to the networking time. Just give me a minute and let me do the breakup rooms, and I will assign you guys to each individual rooms here.
Okay, I'm going to say bye-bye, everybody. Go and play with the puppies. Bye.
All right, let me reopen the rooms again.
Sammy, the recording.